tsunami or Twitter information which is generated at the time of disasters. So it has applicability in social science, humanities, law, and other sites also. So it's not restricted to only computer science and within the domain of computer science. And this is the fourth industrial revolution, and AI, artificial intelligence, is the fourth industrial revolution. You started with what you call the steam engine, then followed by electricity, then it came the internet, and this is the fourth industrial revolution which talks about AI. And all countries across the world are actually looking forward to exploit the situation in terms of use of AI to automate most of the things which they have. That is the focus. So this subject becomes more important, and we know machine learning is a branch of AI. So this subject becomes more relevant in today's scenario, and a lot of countries are into heavy investment in this. So I went to UNESCO Mexico, where I delivered a talk on AI in early warning systems, where it was a UNESCO forum where people from across the world had come, and the focus was on Industry 4, that is the fourth industrial revolution. Then I was there in France, in Lyon, where India had signed a collaboration with France. I was part of the AI and mathematics delegation. There are 10 areas the collaboration took place, of which AI and mathematics was one area. Again, the focus is that, focus on AI today has emerged. And we know that, when the Niti Aayog has come with 5 focus areas for AI, mainly the healthcare, agriculture, education, smart city and infrastructure, and smart mobility and transportation. They're the 5 focus areas. So I've started working, already I work on the area of AI in disasters. I've started working in the area of healthcare and agriculture also. Education is another one focus, which can be very much exploited, because today the learning has to become more customized, more person to person, individual based rather than the class based, because they believe that everybody has their different ways of grasping things, and to understand the level of their grasping and how much time they take to grasp itself is the AI problem. So one thing one has to understand is that AI has not specific to computer science. It has its own various dimensions in terms of its applicability to various areas of social science and humanities as well. So I have many slides, but I will not talk on many slides, but I would focus that, the concept of data science and AI and machine learning are very important today. Because for machine learning to give you accurate results and better results, data is of prime importance. Because if you have enough data, good amount of data, your results are going to be much more reliable and effective in terms of producing quality outputs. That's why today people talk about deep learning, which has emerged out of mainly the neural networks area, but the deep learning requires a lot of data. And today we have the capacity to generate such amount of data, because the sensor devices are located and at different places, the IoTs and all these technology, because of which data is getting generated at a rapid rate. And most of it has to be analyzed in real time. When I say real time, we mean they need not be stored, but they have to be analyzed on the fly, because storage does not have much significance in that regard. So this is the focus. So I will just try to, when I talk about data science, I will try to move from the data itself and then move towards it. I may skip some slides, but let me see what I can talk about. I will start with the initiation of data. We started with something called centralized systems, where there was only one server which was connected to multiple machines. And each of these machines were called dumb terminals. When you say something as dumb terminals, it means it has only keyboard and a monitor, but the processor does not possess any data nor processing capability, and it relies totally on the server for the capability. But gradually what people found that it's a single central point failure, so they wanted to avoid this because the reliability of such system was very low. So they came out with a distributed type of system where instead of relying on a server machine, the data as well as the processing capability gets distributed amongst the various nodes, that is various machines, and these machines are connected through a network. Now, in this case, the reliability is high. Even if one node is failing, the other nodes keep working. Whereas in the prior case, the node containing the server is failed, the entire system goes down. So this is how the database research evolved. The distributed data system itself evolved in different ways. First, it was thought about as a top-down approach, where the system was decomposed to ensure that it is no more a single point failure. But today's scenario, the distributed system is based on the bottom approach, where you try to merge the existing databases to form the system. Then you talk about consolidation, data integration, because today the scenario is that you have many databases which are there, and people like to work on queries that access data in these databases. So for that, you need to consolidate data in these databases. So that is the data integration comes into picture. And that is why, if some people have done databases, they are familiar with the 3-level ANSI Spark architecture. But when you talk about distributed databases, we talk about a 5-level architecture. We have the local schema, which talks about data at its particular local level, and then we have the transform to component schema, export schema, federated schema, and external schema. So in a layman, if you want to understand, I take one very simple example of talking about in a very different perspective, that if suppose somebody, Chinese and Japanese, would like to interact with each other, and Chinese neither knows Japanese, Japanese neither knows Chinese, so they cannot interact. So one local schema happens to be in Chinese, one local schema happens to be in Japanese, but there is no way they can interact because they don't know each other's language. So what they do is they either learn Chinese, learn Japanese, Japanese learn Chinese, or both learn English. So that the component schema comes into picture where both can interact. So suppose both decides to learn English, so the component schema now is in English in both the cases. That is, the Chinese local schema has got transformed into same component schema in English, and similarly Japanese local schema has got transformed into component schema in English. Now at the same time, when they interact, they have autonomy that is with them. They will not interact everything. They will not talk about everything. They would like to share what they want to share, and they will not share what they don't want to share. So then comes what is called the filtering processor, which decides the information they are willing to share. That comes what we call the export schema. That is because of that.
Sir,
yes.
Sorry to disturb, sir. Can you please make it to the slide show mode? Thank you, sir. Thank you so much.
Okay. So it becomes more of filtering processor means, every database has its autonomy. They don't decide, they decide what to share, what not to share. So then the component schema gets filtered, and only that data becomes part of the export schema, which is willing to share. Once this export schema are found, then they together interact and form what we call the federated schema. It's like saying the Japanese and Chinese have decided now to share something in English, but they decide what to share, and then they share the documents which they are willing to share, and they hide the things which they don't want to share. And based on the two documents, a common document is prepared, which is called the federated schema, from which various external schemas are given. Suppose the common document has that information about finance. So there is one external schema that comes out of finance. It may have information about operations, finance, sales. So one external schema will be operations, one will be finance, one will be sales. So actually the 3-level architecture in the case of database gets transformed into what we call the 5-level architecture in the case of distributed database. FDMS is called Federated Distributed Database Management System. The federation means the states, the units, the databases have the autonomy. Non-federated means the databases do not have the autonomy. So that is how you differentiate between a federated and non-federated systems. Then came ontology, because the challenge is not about addressing the syntactical heterogeneity in terms of the model representation. The challenge happens to be the semantic heterogeneity. Why semantic is, people have their own ways of expressing things. So no two people may express the same thing in the same way. Somebody may call it employee ID, somebody may call it employee number, but both means the same. So they are actually called synonyms. the names are same, that does not mean the meaning is same. It's a case of homonyms. The semantic heterogeneity is to address such homonyms, synonyms, and other issues that exist. For this, something called a terminology which was adapted from psychology. This is called ontology. Ontology was defined by Tom Gruber as formal explicit specification for shared conceptualization. It looks very complex, but in a very layman perspective, ontology is actually a common vocabulary. So you create a common vocabulary of terms which gets mapped to the individual terms for the respective data sources, which may be heterogeneous in nature, and maybe semantical heterogeneity may exist between such sources. So the challenge in databases in terms of integration was more towards addressing semantic heterogeneity, and that is where the ontology concept came into picture. Then we talked about warehousing, because we know database is all about doing transactional processing. The focus of databases is to do day-to-day transactions, where it is record-based transactions, but people realize that how do you analyze if you have only one record? And you keep overriding that record again and again in different transactions. Then they thought that if in order to do analysis, you need to have historical information which keeps track of the previous records also, which have been already updated by the subsequent records. So then there came a concept of data warehouse. So if in a layman, if I want to make you understand difference between databases and data warehouse, it is if you update a record in a database 1,000 times, at the end also there is a single record, which is the last update of the record. But when you talk about the data warehouse, when you update a record 1,000 times, there are 1,000 records with different times at different times. So in one case there is only one record. In one case there is 1,000 records, but it keeps track of the previous instances of the same record as well. So the time component comes into picture. The same instance at a different point of time has a different value for some attribute. So warehouse purpose was totally different. As database purpose was more about transaction processing, warehouse purpose was more about analytical processing, and analytical processing required historical records for analysis. So then the concept came of data warehousing, which is a central repository, which integrates information from various data sources. The idea is to keep historical information so that analysis can be done. So we have this region support system, which is created based on the warehouse. There's something, either warehouse is created based on a top-down approach or bottom-up approach. Either you create marts from warehouse or you create warehouse from marts. Marts are very subject-specific domains of a warehouse. Then we know that databases focus on online transaction processing, whereas warehouse talks about analytical processing. And we can understand that one is more of clerical information, clerical processing is done, and on the other side, it is more of a decision maker, strategic processing is done. And definitely when you know that 1,000 times if a record gets updated, there are 1,000 records in a warehouse, whereas there are only one record in a database. So you can easily imagine the size of the warehouse is going to be huge as compared to a database. Then something people are very less familiar in terms of database research is the area of data streams. We talk about the analysis of data and accessing, querying data which is static in nature, that is just the stored form. But there is another aspect of data is the dynamic data which is in the movement, which need not be stored at all. Because there's some data which is in dynamic, is on the fly, is dynamic in nature, but it loses significance after some time. So there is no need to store it. But it has significance for a particular window of time during which it is important and analysis should be done on such data. So there we talk about what is called the stream model. It inputs adapted at more points, and then we have the streaming data that comes into picture. So that actually differentiates between what is called the data-driven and the event-driven situation. Data-driven is more strategic orientation, event-driven is more operation orientation. In data-driven, you talk about human involved, and event-driven, it is automated processes, because you need to analyze the data in a particular window of time. So it is more real-time processing rather than, offline processing, where in the case of other databases. You develop long-time insights, whereas it is real-time responsiveness. It's drive quarterly planning, drive instant interactions that they occur. It determines product strategy. It determines the product itself. Inform marketing campaigns. It selects the marketing campaigns. And time sensitivity is very low in case of data driven. But time sensitivity is very high because it is a real-time responsiveness is there. So it is very high in the case of event-driven. And today, in today's scenario is more event-driven because you need to have real-time responses because any competition in any sort of market or any sort of requirement requires real-time responses because anybody who gets the things faster is not all about correctness. Correctness is important, but correctness has sometimes loses significance if it is not on time. So today the idea is to get the correctness within a particular time, and that is most important. So then you have what you call the data stream management, where you talk about very closely precision, sample size, sliding window size. Then you talk about how you manage the streams of data, and then you talk about how you analyze the streaming data. The only difference is one way we talk about analysis of something which is stored, and somewhere on the line we talk about analysis something which is not stored, which is on the fly. And the very important example in such a scenario happens to be the stock market analysis, where the stock price keeps changing and people have to make decisions in real time whether to buy or sell a stock. So this is an ideal example for what you call the data stream management. Then people today talk about big data. Sometimes people believe that big data is something new. Actually, it is not. It is all about, the technology which has enabled people to capture the data. And gradually the data has exploded in such a manner that it is not only voluminous in terms of size because of the amount of data that is generated through various devices. It has also become very heterogeneous in terms of the type of data that is being produced. It is video data, it is audio data, it is picture data, it is text data. There is a lot of heterogeneity. And the speed at which it is getting produced because of these sensor devices, that creates what you call the velocity of data. And the most important aspect which one should not forget is today you have in the internet also a lot of data which is getting generated at a rapid rate. But at the same time, you have to be very careful in terms of which data is trustworthy and which is not. Because unless you know the trustworthy data, it becomes difficult to decide what data to analyze. Analyzing any data is not going to be productive enough. So you need to identify data which can be trustworthy, and that is what we call the veracity of information. So that's why certain V's are associated with big data. But if somebody asks me what is this difference between, there's something called small data. There's something called data and there is something called big data. If somebody asks me what is the difference between data and big data, the simple difference is if something which is applicable for data cannot be used for something, another form of data, that data is formed in. For example, suppose I take a very realistic example of a small hammer to break a chair. And I end up breaking a chair with a small hammer, but if you expect me to break a wall with that small hammer, it won't work. Because wall has its own complexity, something that is applicable for small is no more applicable for large, and that large is good enough in terms of its complexity, in terms of volume, in terms of the way it is getting generated, or in terms of its heterogeneity that makes it more complex. So some techniques and tools and technologies which were applicable for data were no more applicable for something big, makes it big data. Now, why this big data is complex? One can easily, again, another example which I popularly take is the issue of, a student preparing for an exam. Usually, if you ask a student, and if you want a student to perform well in an exam, you have suppose you are being given two options. Suppose you take maybe 5 chapters you take after 5 days. Would you prefer that? Or would you prefer that a student takes exam of every chapter every day? But the answer is very simple. It's every chapter every day will always give you better results than 5 chapters after 5 days. The reason is not you have 5 days to prepare for 5 chapters. It is about the quality of understanding of a subject will matter. And what I can make you understand is, When you try to understand a word, it's still easier to understand a word than a line. Line is easier to understand than a set of lines. Set of lines is easier to understand than a paragraph. Paragraph is easier to understand than a section. Section is easier to understand than a set of sections, and set of section is easier to understand than a chapter. Chapter is easy to understand than a set of chapters, and a set of chapter is easier to understand than a book. So as the size grows, the complexity grows. So something which you could have made for understanding a paragraph, the quality of understanding a paragraph is going to be much better as compared to understanding a chapter, and similarly understanding a chapter is going to be much better than understanding the 5 chapters which are there for the exam. So the techniques that were performing so well for one chapter actually fails miserably when you are given 5 chapters to prepare, even if you have time. The quality of understanding deteriorates. And that is where the analogy of big data comes into picture. And that is how we differentiate between what data and a big data is. So, for example, today the situation has changed. It's an example where today people want to have precision in terms of the quality, so that they want to avoid, any crashes. They want to store all data related to airline flights. So increase sensor-enabled and instrument business environment, and this huge volume of data with machine space and 1 billion lines of code each engine generates in 30 minutes. Just imagine the amount of data that is getting generated and today captured and stored. And people are looking forward to analyzing such data. Sometimes we are so novice in terms of posting pictures, and sometimes we don't understand it's not the picture enough is good enough today. People are focusing not on picture mainly, they can focus on their metadata to understand lot of things about you. Since the photo was taken by a smartphone, the image contained metadata revealing the exact geographical location the photo was taken. By simply taking a posting of photos, Savage revealed the exact location of his home, the vehicle he drives, and the time he leaves for work. Today, people are into that information. They're not only looking forward to seeing anybody's photo, but they want to see the metadata that is associated with these photos. Again, we have the Facebook information. So Facebook is sometimes we are very much informal in Facebook, but sometimes we within this informality, the challenge happens to be to find information which can be of great help. So something like, Pauline and have happy birthday, Pauline, I can't believe you and your son. So you're actually revealing your birth date during this. And somebody wants to buy an iPhone. So he's actually revealing that he's looking forward to buying some phone. Now, out of so much informal talk, which may happen to be 90%, there may be 10% which may a talk which is informal, but may carry some information which can be beneficial to business. So people are working towards this data to understand. So what has happened is this is revealing your name, birthday, and family. They are not mainly going to be noise, and this reveals what is their monetization intent. Somebody wants to buy some phone, and the business person knows how he can follow and give some schemes to him so that he's likely to buy the phone. So what is big data? As I've already told, big data refers to collection of data sets so large and complex it's impossible for them with the usual database tools. As I said, the techniques which are applicable for small are no more applicable for large. The techniques and tools and technologies which were there for data is no more applicable for big data because of its complexity that is there. There are many sources of big data. It can be mobile devices, RFIDs, sensor networks, social networks, internet searches, automated record keeping, video archives, e-commerce. Not only this is big data, even the analysis out of this is also huge. Today we talk about data of the level of 35 gigabytes, and that is how, and you can just understand 500 plus terabytes data is produced by Facebook every day. And today people are looking forward to exploiting such data for analysis. As I already said, we talk about volume, data at rest, velocity is data in motion, variety is data in many forms, and veracity, which happens to be the most important characteristics of data, is the data in doubt. That means you have to be very careful when you analyze, because you cannot analyze all data. You need to identify data with a trust level which is trustworthy. Then do analysis. Only identify first the trustworthy data and then do analysis on the data. Now the model has changed over a period of time. It is no more industries are producing data and you are consuming it. Today, everybody is carrying smart devices, smartphones, and other devices which they are carrying. So now today the scenario has become that everybody is producing data and everybody is consuming it. So totally the focus has changed, the modeling has changed. The old model was only focusing on just using data produced by somebody else. But today, we are all using data which is produced by everybody, and everybody is using that data for analysis. So now, as I said, in databases, we talk about transaction processing. When we move to warehouse, we talk about analytical processing. And today's scenario where we want to be more real-time responsiveness, so we talk about real-time analytical processing, because we need to talk about analysis in real time. The bottleneck is in technology. The new architecture algorithm techniques are needed because the ones which exist now are no more applicable for large. Also, the technical skills is very much required. Experts in using new technology and dealing with big data is required, because people have ability to work with small data, but somehow they don't understand the big data because of its complexity. So that's why they are looking forward to technology as well as the expertise. Okay. So let me have a break. Okay. So the big data conundrum happens to be that, today, earlier we were saying that we did not have data, so we had excuse of that, what type of analysis we can do. But today the scenario has changed. You have a lot of data, but you are not able to analyze them. So that because you don't have tools and technologies that can analyze them. So the challenge is the excuse which was there earlier is no more an excuse today. Today you make an excuse that, you have data, but you don't have tools and technologies that can be used for performing analysis on data. So the ultimate goal happens to be based on this pyramid, which is based on something called data, which needs to be processed to give some meaning to it, which is called information. From information, you infer something very interesting, some interesting pattern out of it, that is called knowledge. But knowledgeable person is of no use unless he knows how to apply the knowledge. The actionable knowledge happens to be called wisdom. Now, very simple example, if you come to day-to-day life, is when you sing and the voice does not come on outside, and you sing within yourself, you feel that you're a great singer or you are a great orator. But when the voice comes out, you actually realize how good a singer you are. So there is a difference between that. That is the line between knowledge and wisdom. Perception, you may have a perception that you have knowledge, but unless you apply it, you can't be sure it is knowledge. So wisdom enables you to not only, it enables you to validate the knowledge. So it's like saying knowledge is singing inside without the voice coming outside. You believe you can sing well. Wisdom is, when the voice comes outside, you actually realize how good a singer you are. So it's the actionable knowledge happens to be what we call the wisdom. The ultimate goal is to find wisdom from data. Wisdom validates the knowledge, and if the knowledge is there, it enables you to utilize the knowledge. That is the importance of what we call wisdom. So what is data science? Data science is all about finding this wisdom from data. Data science is an interesting field that uses scientific methods, process algorithms, and systems to extract knowledge and insights from data in various forms, both structured and unstructured, similar to data mining. It unifies various concepts. It's not only restricted to computer science. It talks about unifying statistics, data analysis, machine learning, and related methods in order to understand and analyze actual phenomena with data. It employs techniques and theories drawn from many fields within the context of mathematics, statistics, information science, and computer science. It is the fourth paradigm of science. It's empirical, theoretical, computational, and now it becomes data-driven. So it has stages. We talk about data science. It has data acquisition, data preparation, data mining and modeling, visualization and action, and model recomputation. Acquisition is extracting data from multiple data sources, integrating and transform the data into homogeneous formats, loading the transformed data into a data warehouse. It's like an ETL. You transform it, you extract it, you transform it, and you load it in a form. Then you have data preparation, because whatever data you have may have data cleaning, because there may be case of missing and null values. They need data transformation because they may have different scales in which they exist. So you may do either normalization or you do standardization. Either you may require to convert a categorical into a numerical data. Then you have handling outliers, can be used for fraud detection. You have to identify what are the outliers in terms of information that is available. Then you have data integrity. accuracy and reliability of data, you need to measure how good or reliable the data is. Then only you can take care of its analysis. And then data reduction, it can be removing duplicate rows or columns. You may have a lot of redundant data. So either you remove rows or columns, and when you talk about data reduction, we can also talk about something called feature selection or feature extraction. Because based on dimensional reduction, you may have so many dimensions, but all dimensions may not have equal importance. When you talk about only few dimensions, you can easily identify which are of importance. Then you talk about selection. But when you see that all the dimensions have some level of some weightage of importance to some solving a problem, then you talk about using extraction. So in either case, you reduce the dimensionality of data because then you can actually use the data for processing. Because higher dimensional data becomes very much complex to process or computationally expensive to process. Then something called data mining comes into picture. It's a process of semi-automating and analyzing large database to find patterns. Patterns are not valid because they exist in data. They are novel because such patterns were never conceptualized or perceived in the past. They're useful because since they were not perceived in the past, there was no strategy for it. So they are useful and they are understandable. Because understandable means humans should be able to understand and only they can work using it. The famous example in data mining happens to be the beer and diaper example, where one time it was trying to find out what items were bought together more frequently, of which many other items came along with something very unusual came is that beer and diaper are bought very frequently together. Now this is valid because this information came out of data. It is novel because nobody would have ever perceived that beer and diaper could have any relation with each other. However, the data was showing that they are bought together most often. It is useful because people did not have a strategy for beer and diaper. So now they had a strategy for beer and diaper and they were existing this. Please hold it. Please. Hello. So it is understandable. So beer and diaper people useful because there was no strategy available with that, and therefore they could form a new strategy because there was nobody knew that beer and diaper can have any connection with each other. To understand why we bought together often. Some people said on a weekend people went to for a long drive. On a long drive they had drank beer. They were more towards drinking beer and have diaper for the child. Or people watching, American football matches on the weekend, they were drinking beer and not get disturbed by the child, they had diaper. So there are many interpretations that came out. But in either case, this is where the data mining comes into picture. Something which is very novel. One could not have perceived, and it makes sense. If somebody says, somebody buys a bread and a butter together, it's not novel at all. It is not novel at all. It has its own significance. It is not novel. So that is the case of mine. Then again, something came up is web mining. When one came up with web mining. Please. Then came something called web mining. Again, people try to understand why something is called web mining. It could have been easily called data mining, but they wanted to differentiate that mining data should be different from mining structured data. They wanted to understand the difference between mining data and mining structured data. Now they wanted to wanted to differentiate that we have been calling using data mining word when you talk about mining structured data. But what do we call something as mining unstructured data? They wanted to use data mining, then somebody said that, data mining will not be, will look similar to something or structured. So they wanted to understand that can we coin a different name for this? Then they decided to coin something called, what you call is the web mining. Now, web mining is all about talking about something called what you call is the unstructured data. Why web mining? Because most of the data in web is unstructured in nature. So they came out with the term what you call is web mining. Then came the picture is then something called AI came into picture. Now, artificial intelligence, some people remember artificial intelligence is the ability of machines to perform cognitive tasks like thinking, perceiving, learning, and solving and problem by hand. Hello. Sorry, there was somebody on the doors. Okay. Then something called is AI. AI refers to ability of a machine to perform cognitive tasks. Now, AI was supposed to be assumed to be very something which is going to achieve a bigger, achievement in terms of its thing. So they overestimated AI in 90s when they started working on AI. They overestimated it. They believed that they could have machines which are easily going to behave like humans, but that did not happen. That actually did not happen because what they made a mistake was they underestimated humans, though they overestimated AI. Because humans was very complex, and you could not have expected. And that's why that led to what they tried to segregate AI and classify AI into something called weak AI and strong AI. Weak AI is something which exists today in machines, which is based on simulation. It is based on what you call simulation. It does not have any consciousness. Even if you have come across a chatbot, it does not have any consciousness. And there is something called strong AI, which has consciousness in picture. So there is some consciousness associated with strong AI. So there is consciousness. So that is how you differentiate between weak AI and strong AI. So today, when you talk about humans, there is consciousness. And that is missing in today's machine, which is based totally on simulation. Then there is something other is called what is called the narrow AI and generic AI. Now, narrow AI is today's machines are ability to perform single task. Today's machines are able to perform single task, but the machines are not able to perform multiple tasks today. So the point is, machines are not able to perform multiple tasks. So they require these machines to have ability to perform multiple tasks. Even if you talk about using these games, Tic-Tac-Toe, and today you have tools which are able to produce games which are like Tic-Tac-Toe and other things. But the same tools cannot play other games. Like, how talk about the Deep Blue machine, which had an ability to play chess. But you cannot expect Deep Blue machines to play any other sport. So, but when you talk about humans have ability to perform multiple tasks. And since humans have ability to perform multiple tasks, today these multiple tasks are not available in case of machines. So it was classified as something called narrow AI and something called and weak AI. So narrow AI means the machines today which exist, which are able to perform only a single task, and generic AI is machines have an ability to perform multiple tasks. What people aspire to have is called super intelligence, which is a combination of both generic AI and strong AI. Then people are familiar with Turing for different reasons. He has been instrumental behind the Turing machine. He was also instrumental behind the the winning of the World War II by the Allied forces. But there is something called Turing test in artificial intelligence, which is all about ability of a machine. If you are not able to find whether a machine on the other side there is a machine or a human, it's like that. If you try to keep a curtain between a human and a machine, and the machine starts to interact with the human, and there is no way you can find out whether on the other side there's a machine, that day the Turing test pass. But if you know Stephen Hawking, he has actually mentioned that the day AI succeeds, that will be the end of humanity. Because he believes that if AI can be used in constructive, and in case it is used in destructive manner, it can be very harmful to the humanity. Today we come across situation where we talk about animal zoos, but when AI succeeds, you may come across zoos which may have humans. Then you talk about one branch of AI which happens to be called machine learning. Machine learning is an application of AI that provides systems that ability to automate, learn, and improve from experience without being explicitly programmed. The process of learning begins with observation of data such as examples, direct experience, or instructions in order to look for patterns in data. The primary goal of machine learning is to allow computer learns automatically without human interventions. And machine learning itself gets classified into three types: supervised, unsupervised, and reinforcement learning. When you talk about supervised learning, it can apply. The supervised learning is all about the learning which is supervised by some already existing data, which is already have classes already tagged with them. An ideal example is like, suppose you want to buy a credit card, and you are and all the previous customers who are actually in possession of credit card are already defined as good and bad customers. I hope I'm being heard. I hope it. You can hear me. Hello. Oh, okay.
Yes, sir. It's not.
So the supervised learning is all about having it is supervised based on the past records, the labeled data which is already exist. The label is in terms of the classes which are already exist in the data. Now, starting from analysis, knowing training data. So the one very good example of supervised learning happens to be the credit card scenario. Everybody applies for credit card, but not all of them get it. But sometimes people get surprised. Whether they have this credit card or not. Sometimes people get surprised about it. So why they get surprised? Because people are running after you to buy credit cards, and at the end of the day, you don't get a credit card. But why such a thing happens? Because in the past data, people have already identified good customers and bad customers. In the past data, people have identified good customers and bad customers based on the data. Now, what has happened is that already the good customers and bad customers have been identified. Now, that data is used for training the model. And based on that model, a model gets created. Now, for a new customer, you don't know the label. You don't know whether a new customer happens to be a good customer or a bad customer. So what you do is use data and apply to this model, which is already based on labeled data. And that data gets classified as good and bad. If you are good, you get a credit card. And if you are bad, you don't get a credit card. And similarly, there is regression. Regression happens to be a statistical technique for estimating relationship among variables. It estimates relationship between a dependent variable called the outcome variable or response variable and one or more independent variables. The most common form of regression analysis is linear regression, in which a researcher finds the line that most closely fits the data according to it. Now, regression is based on prediction. Now, prediction is based on the weighted combination of various attributes. Some weights are more and some weights are less. And the other way of supervised learning happens to be what we call this classification. As I said, from the previous data, you use to previous data to train the model, and then use that model to predict the future data. It's like saying that if you have a previous data in this form, you have the previous data in this form. Then you use this data in the field. So if you see on the left-hand side, there is a table which has got these classes, no and yes. And there are 5 data which happens to be with a question mark. Now, these labels are already there. There are 15 records of the past for which you use the first 10 records for training the model and the rest 5 for validating the model. Once you have a level of accuracy for a model after validating it, you use that model for future data. So for future data only, you put the values of attribute 1, attribute 2, attribute 3, and the future data classifies. So it's like saying that yes and no can be whether you give a credit card or not. And in the future data, you get to get the value whether it is yes or no. Then comes something called unsupervised learning. Now, unsupervised learning is where you have no prior information about the classes for data. You have no prior information about the classes of data, and you create those classes out of data. That is called what you call as unsupervised learning. The techniques which are used for unsupervised learning are clustering and association rule learning. Now, clustering is an example, is a process of partitioning a set of data into a set of meaningful subclusters. Now, this is one very relevant example of clustering happens to be when all students come to a new class. Nobody knows each other. But initially, they talk with each other, and accordingly, they based on the system, they realize, understand each other. So that is how you define the classes. So, understand each other. That is clustering. Okay. So, if you see in the beginning, the students interact with each and every student of the class. And after 1 month, you find that there's a group of students that created within a class. Each such group is called a cluster. So that group is based on the similarity. Some students who study hard become one group. Some students who play sports become one group. Some students who go around here and there, they form one group. And this is the basis of what you call as clustering. Now, clustering can be itself be partition-based, hierarchy-based, density-based. So one example of clustering happens to be what you use the K-means method. K-means, K stands for the number of clusters. So you have 3 centroids. When you define the number of clusters you want to find, if suppose you have set 3K as 3, then there are 3 centroids. Based on the centroids, you try to identify the points which are closer to these centroids, and then based on the close proximity of the points to the centroid, you associate the points to the corresponding centroids, and those centroids form the cluster. So you can see here, red form one cluster, green form another cluster, and blue form the third cluster. So that is how it finds. So you have this way of creating clusters. Then there are another way of unsupervised learning happens to be association rule mining. The idea of association rule mining happens to be, using these various classes of things. This is an example of the situation where you talk about the beer and diaper, where we want to try to find out what items are brought together more frequently. So there is a basis for which you use the support and the confidence to find such items. So you base it based on minimum support and minimum confidence, and there is a very famous algorithm in terms of the a priori algorithm which enables you to do this. But this has its own focus. It also comes under unsupervised learning because you are looking forward to find which items are brought together more frequently. Something third, which is another focus of machine learning, happens to be reinforcement learning. This is something which you come across while playing video games or any sort of games, because at games, the ultimate goal is to increase the output, increase the reward of the game. The ultimate goal happens to be increase the reward. So what you do is you try to hit and trial, you keep doing it, and every time you learn from it, learn from the environment, and get better rewards. And that is how you score more and more points. Focus is to find balance between exploration and exploitation. A learning method interacts with an environment producing action and discover errors or rewards. It's a trial and error search, and delayed reward are the most relevant characteristics of reinforcement learning. It's like, riding a bicycle. Initially, you don't know. You make errors, you fall down here and there, then you keep understanding, and suddenly you start driving, doing it properly. But this is all based on something called very relevant to what your reinforcement learning is all about. It is a simple reward feedback is required to the agent to learn which action is best. This is known as reinforcement signal. So this has its own concept of goal of reinforcement learning agents to collect as much reward as possible. The agent can choose any action as a function of history. It has been applied successfully to various problems, including robot control and elevator scheduling. And that is where the company comes into picture. Then once you have learned something from data, then comes visualization and action. The results of modeling are presented in a meaningful manner, interpreted using various visualization tools for decision making. The decisions arrived at are put into action for its applicability in the real world. Then you have model recomputation. Why model recomputation comes into picture? Because the point is data keeps changing. And the old data becomes less relevant, new data becomes more relevant. So you need to keep updating, recomputing the model based on newer and newer data. So it's like saying, and then you need to update it because the model will keep changing. So data characteristics of data changes over time, and the accuracy of the model deteriorates. Model needs to be recomputed or updated periodically to cater to new data produced since the present model was recomputed. Model recomputation results in better accuracy. Then what is all about this analytics we talk about? We do analytics, but there are 5 stages of analytics which is important. Then we start from descriptive analysis and move towards the decisive analytics. Descriptive is a set of techniques for reviewing and examining the data sets to understand the data and analyze business performance, what has happened. Diagnostic is all about a set of techniques for determining the reason of the problem, why this problem has occurred. You try to one. Then you do predictive analytics, a set of techniques that analyze current and historical data to predict the future. That is what is predictive. Then you talk about prescriptive analytics in terms of the alternate mode of actions, analyzing the alternatives that can become a course of action. And the decisive is to select the appropriate alternative that can be used for a particular solving. So the decisive talks about the wisdom, the proper action that needs to be done on the data to get better results. So is big data the same as data science? Or big data science may not be. They have a lot of things. In big data science looks to create models that capture the underlying patterns of complex systems and codify these model information working capabilities. Big data looks to collect and manage large amounts of varied data to serve large-scale web applications. Okay. Wait. Excuse me. Are you able to hear? Are you able to hear?
Yes, sir. Yes, sir. We are able to hear. Yes,
I think the slide.
We are able to hear.
Wait. The slide has gone, no? It appears.
Now it's slide. Yes, sir. Yes, sir.
It has come now again.
No, sir. Yes, sir. It's coming.
Okay. So how is big data same as
yes,
data
sir.
science?
Please make it to the slideshow mode.
Okay. Data science looks to create models that capture the underlying patterns of complex systems and codify these models into working applications. Where big data looks to collect and manage large amounts of varied data to serve large-scale web applications and vast sensor networks. Data science and big data can be summarized in one stage. Collecting is not all about discovering. So a lot of people have this confusion. But data science is not all about only big data. It is small data also can be called data science. And everything with big data is not called data science at the same time. So there is a lot of overlap between data science and big data. But there is a lot of commonalities. At the same time, there is a lot of differences which exist between them. One is collecting and one is analyzing. And that is where it differs. And then something called nature-inspired intelligence comes into picture. Here I will try to end my talk. Nature-inspired is, something which, again, another area which I have been working. We do a lot of things, but we don't understand, the creatures in real life has more, sometimes they don't learn, they don't have education, but they are more intelligent. Sometimes whenever I deliver talk in this area, I always say sometimes, the creatures in real life are sometimes more intelligent than humans because they adapt in such a optimized manner to get things done. For example, ants have an ability to search for food in such a manner that they have this social organized structure. But any ant finds food, it informs the other ants through the environment, through the surface, whether the food exists or not. That is ants. Similarly, the birds which are flying in the V, every bird is trying to look for a space, look for a place of rest, and they look for a place of rest and they are communicating with each other. The only difference between ants and the birds are ants are asynchronous, they lay pheromone on the ground and other ants follow it. Whereas in the case of birds, they are synchronous because they are communicating with each other while they are flying. Bees have another way. They perform dances in the honeybee comb, and dances are a mode of information to other bees. And then there is cuckoo search, which lay egg in other birds' nest. so that it is not able the other bird is not able to distinguish the egg sacs from the cuckoo's egg, and that is how it is able to identify those nests. And this is based. So when you talk about ants, there is algorithm that has been inspired by ants, the ant colony optimization. Birds, it's particle swarm optimization. Bees, it is honeybee optimization, and then research algorithm based on this. So this was my focus on top of this machine learning and data science. But there is a lot of common, but then data science it cannot work unless there is the use of machine learning into it. So that is the focus I want to discuss. If you have any questions, you can just put your questions forward.
Bunny, wait.
If you have any questions, you can ask.
Participants, are there any questions from your side? Any questions from the participants' side? And sir, actually, there is one question in the chat box.
What is that?
That is what is data mart and how it is related to data warehouse?
No, data mart is a small subset which comes out of warehouse. Like, data warehouse is a subject specific aspect. It has got finance, it has got operation, it has got marketing. When focus on one subject is derived, it forms a data mart. That's why either a warehouse gets constructed from data marts, or you construct data warehouse from or you create marts from data warehouse. Warehouse is subject specific. You have many subjects when you talk about a warehouse. Marts is very small subject specific, which comes out of a warehouse. So that's why data marts is something which can be either used to create a warehouse or it can be derived from the warehouse. That is very clear. But anything else?
Thank you, sir, so much. I think there will be some questions on the YouTube session. So probably I do not have that open with me at this moment. So I will go through all those questions, and may I contact you through?
Okay, no problems. If anybody has to ask questions, they can ask. Otherwise, we can stop here. But one thing is for sure that work on this area of machine learning, AI, because this is the area for future. And the most important thing you have to understand